All right, we're calibrating the pH meter. First, we're going to go to the LabQuest app, hit sensors, then hit calibrate, then hit CH1pH, and hit calibrate now. Now we're going to grab our electrode and slide the cap for the storage bottle upwards, not down, because if you slide it down, it might damage the electrode. So we're sliding it down right now.
Good?
Yeah.
Also good?
Yeah.
Now we're going to use the wash bottle to rinse it off because we want to keep it wet the entire time. We don't want it to dry out.
Now you stick it in that one.
Now we're going to dip the electrode in the pH 7 buffer. And we're going to do that until the live voltage stops changing. Then we're going to hit the 7.00 pH value. Hit keep.
Now wash it off.
Now we're going to rinse it off with the wash bottle again. Once again, that's just to keep it wet. Now we're going to dip the electrode in the pH 4 buffer and basically do the same thing. Wait for the live voltage to stop changing.
This is the 4.0.
Okay, now we're going to hit into the 4.00 pH value. Hit keep.
You don't have to move as much to be able to see the screen now.
Now click OK. Alright, now rinse it
Now
off
our
again.
pH is calibrated because the pH reading says 4.00. Now we're going to rinse it off with the wash bottle again. And we're going to find the pH value of the orange juice. We're going to put in the orange juice and wait for the pH value on the meter to slow down. And as you can see, we received roughly a 3.91 pH reading for the orange juice, as I'm writing down here.
I'm right-handed. And now rinse it off.
Yeah, rinse it off again.
Now we're going to rinse off the electrode
And then you're
again
gonna
to
stick
keep
it back in
the
the
orange
storage.
juice off of it, and also to, like I said, to keep it wet.
Yep, the little bottle. Yep.
Now we're going to put the electrode back in the storage bottle and slide upward.
How do you, but you don't.
And there we go.
Yeah.
There it is.
A little bit extra information about this lab. We're strong acids, and strong acids fully dissociate in water to produce the maximum number of hydrogen protons, whereas weak acids do not fully dissociate in water and they only give small numbers of hydrogen protons. And since a strong acid will completely transfer its hydrogen protons to the solvent, the products in the reaction will be favored, or the equilibrium constant value will be greater than 1. And they don't completely transfer their hydrogen protons to the solvent, the reactants in the reaction will be favored, and the equilibrium constant will be less than 1. And basically a buffer solution is an aqueous solution that can resist significant changes in the pH levels after a buffer's pH effectively neutralizes the added acid or base while maintaining.
Calibrate now. Calibrate now. Yeah. Now. Now, you rinse it off. Keep going until the voltage stops changing. Now click OK. Now you rinse it off and then put in the apple juice. And you can just write it in mind of it. Alright, now write it.
Why is there only one? Yeah, if you're analyzing the principles, slow down. Oh, that's good. Just know that you can definitely. Okay. Then for this one, I didn't see. Yeah, I didn't see it. I saw this one, right? But it has to be CO H6, and this one's CO2. Sorry, CO. Right? Make sure you get it. You got it.